Okay, today's lesson is a fairly simple, straightforward lesson. It's a review lesson actually on perimeter and area. And so I wanted to go over some definitions first. A polygon. A polygon is a closed plane figure formed by three or more line segments that intersect only at their vertices or endpoints. What does vertices mean? Vertices are these are the points here. There's one, here's two, here's three on this triangle. This is definitely a polygon. Polygons could also mean something like this. It has vertices here, 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 and here. That's definitely a polygon as well. Here's another polygon here, which is really a trapezoid. There's a vertices there, and a vertices there. So these these three figures here are examples of polygons. Now, what's a non-example of a polygon? A non-example of a polygon would mean that there are no vertices. Can you think of a figure that has no vertices? Well, how about a circle? A circle has no vertices, are there? So this is not considered a polygon. Okay, let's continue on. If you haven't done so, if you could pause, make sure that you write your definitions here. So take out that notebook that we haven't been using for a while, and if you've lost your notebook, you need to write this on a separate sheet of paper here. Okay? So do that. Pause, copy the definition, and then let's move on here. Perimeter. What is a perimeter? Perimeter is the sum of the lengths of the sides of a polygon. So perimeter simply means I've got a figure like this, a rectangle, excuse me, that is 3 centimeters in height, 5 centimeters that goes across. A perimeter simply means we are adding the sums of the length or the sides of the whole polygon here. Okay? Notice how there are 4 sides, and so there are 4 numbers to add. And so I would start by adding this here, the 5 centimeters, 5 centimeters. Then I would also add the 3 centimeters here, 3 centimeters there. And then I would also add, what would be the length of this here? That would actually be the same as the 5 centimeters in the bottom, because they are parallel lines, and so they do have the same equal distance. And so that would also be 5 centimeters, which I need to add here, 5 centimeters. And lastly, I would be adding the length of this here, the height, which once again is the same as this height here. That's 3 centimeters. This is going to be 3 centimeters as well. So that's exactly what I do. I total this up. I see the 5 plus the 5 is 10, 13, 14, 15, 16. So the perimeter is a total of 16 centimeters. Okay, scrolling down, area. The area is the number of non-overlapping unit squares needed to cover a given surface. This is the official textbook definition of an area. Let me take a moment right now to pause the video to copy down this definition as well. I do recommend you copying down this example in your notes. This is what I'll be looking for tomorrow as well. You can do that right now. Pause the video, and then pause it when you are done. Okay, so let's move on here. So here's an example of an area. Um, so I've got something that is 4 units as a height and 9 units going across. Literally, the area is wanting to know how many of these individual unit squares that are non-overlapping. Notice how this one here and this one here are not overlapping from each other. How many of these how many squares are going to be able to fit in this little box here? That's the area. And so, I mean, I could always draw it on a grid And I could literally count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 29, 30, 31, 32, 33, 34, 35, 36. There are 36 little squares that can fit in here. But that would take a little too long to do on a regular basis. So mathematicians have come up with a shortcut. And that shortcut is, notice how this is 9 units across and 4 units going up and down. And so using simple multiplication, which is area, excuse me here, let me rewrite that. Area, oopsie, equals to base times height. And that base is the 9 units that you see times the height of 4, which gives me 36 unit square. Okay? I do want to point out that writing down the units are very important. This was 9 units multiplied by 4 units. And as we multiply the numbers together, 9 times 4, we really are multiplying the units together as well. And if you remember from our exponents, units times units is going to give me units squared. Okay, so if you ever wondered where we get that squared from, it's that as well. All right. If you have any questions, please write them on the side. Have your notes ready for tomorrow, and I will see you then. Okay, bye-bye.